Hello everyone and welcome back to Operating Systems lecture. We were discussing concurrency and synchronization, and in this video we are going to study one of the classical synchronization problem, that is sleeping Barber problem. Right? So let us start. Now talking about the problem, right? So the first what we have with us is a problem statement where we have certain processes competing to execute their critical section, right? So similarly in this particular problem also we have two processes who actually wants to execute in their critical section, right? So the one process is the Barber process and the other one is the customer process. So we have two processes, right? And they are trying to actually work upon certain shared variable. That is why it is mandatory that they shouldn't be executing their critical sections together, right? So what is the scenario? The scenario is keeping the barber working when there are customers, right? So whenever we have customers in the shop, right, the barber needs to be working. That means it is essential for the barber to cut the hairs if there is any customer in the shop. So first requirement is this. The second one is keeping the barber resting when there are no customers. So as the problem name suggests, it is sleeping barber problem. So as soon as the shop is empty of its customer, what the barber should be doing? It should be sleeping. So barber is meant to do only two tasks. First is to cut the hairs and the second one is to sleep if there is no customer, right? So only two tasks are there for the barber to do, right? And the third one is we have one barber chair and a waiting room with a numbers of chairs. So what we have with us, we have a barber chair, right? So barber is sitting on a chair. So one is this particular resource, the chair, and there are certain chairs which are empty and they are in the waiting room. So what is the scenario? The scenario is if there is no customer in the shop, the barber will be occupying that particular chair and he will be sleeping, right? As soon as there is a customer in the shop, that customer will go and sit at the waiting chairs, one of the waiting chairs. The barber will go to the waiting room and see if there is any customer. If he finds any customer, he is going to fetch that customer to his chair and then he will be cutting the hairs, right? So that is the process. And one thing that we need to understand over here, because this is a critical section problem which we are actually understanding as a form of a story, right? As the reader-writer problem or producer-consumer problem. So we have certain scenarios, and in each scenarios what we should have some shared variables, right, or shared data onto which both the processes are actually trying to work upon, right? So here the shared variable with us is the number of free chairs that are available in the waiting room, right? Because you can see that the customer is actually also interacting with the chairs and the barber is also over here is interacting with the chairs, right? So both the processes are trying to interact with the chairs. That is why this is the shared resource, right? And this can give rise to race condition which we are aiming to avoid, right? So let us move further. These are the roles of the barbers and the customer. It is a very important classical synchronization problem. So here I am teaching it in a pretty detail, right? So you can see about the roles of the barbers first. When the barber finishes cutting the hairs, he dismisses a customer and go to the waiting room to see if there are other customers waiting. That is the same thing that I just told you in the previous slide. Now, if there are waiting customers, he brings one of the chair, he brings one of the customer to his chair and starts cutting their hairs, right? That is also I have explained in the previous slide, right? And if there are no customers, then he returns to his chair and sleeps. So that is the work which is actually performed by the barber process. Now coming to the customer process, each customer on arrival sees what the barber is doing, right? Now if the barber is sleeping, he wakes him up and sits on his chair so that the barber can cut their hair, right? So these are the 2 points important. Now if the barber is cutting hair, he goes to the waiting room, right? Because he must wait, because barber is busy with some other customer, right? So he goes to the waiting room, and if there is any free chair in the waiting room, then that customer is going to occupy that chair and wait for the barber to get free. Otherwise the customer will leave the shop, right? So these are certain tasks which are performed by the barber and the customer process, right? Make sure that they are all working with that shared resource, which is the chairs. Now that is the key point you should keep in mind. So the problem, if I say, more precisely in proper language, the problem is to design a solution which executes both the processes synchronously, avoiding both the race condition and the deadlock. Right, so this is the official statement of sleeping barber problem, because obviously we want both the barber and the customer process to work on, and we do not want any deadlock condition or race condition, right? So on your screen there is a small code like structure, you can call it a pseudo code of the barber process. Now remember that there are 2 processes, barber and customer processes, and they will be working simultaneously independent of each other. So what is the main aim of writing this particular pseudo code is to avoid race condition and deadlock, right? So let us see this particular code over here. Now you can see the bold portion, that is this one. Here we have certain variables defined. So the first variable that we have with us is the semaphores, right? So we have 3 semaphores over here. The first one is cust ready, that is customer ready, which is initialized to 0. Second one is semaphore again, which is barber ready, which is again initialized to 0. The third semaphore is access to waiting room seats. See, access WR seats means access to waiting room seats, and it is initialized as 1, right? And another integer number is over here is defined, which is number of free seats, that is n, right? So we have these 4 things with us. Now let us see what it is. So the first one, which is cust ready, right? It is actually notifying the barber. Remember the process, if the customer enters into the shop and he sees that the barber is sleeping, then he will be waking up the barber, right? That I am here, please cut my hairs, right? So the cust ready semaphore is being used to notify the barber, right? Similarly, the second semaphore, that is the barber ready, it notifies the customer, right? If the barber is actually right now cutting somebody's hairs, now that particular person goes off, now the barber is ready and it will be going to the waiting room, right, and asking the customers, please one of them now come to my seat and I will be cutting your hairs, right? So this particular semaphore, second one, barber ready, is for the notification for the customers, right? Then the third one, access to waiting room seats, right? Now access to waiting room seat imposes mutual exclusion on room seats, right? So we know that semaphore value is used to actually implement mutual exclusion. So because both the barber and the customer process during their particular execution are going to manipulate this variable, right? Customer are going to decrease the number of seats, free seats, and barber is going to increase the number of free seats, right? That means the both barber process as well as the customer process will be trying to work on this particular variable, that is number of free seats, right? Both cannot operate on it at the same time, and that will be leading to your race condition. So in order to get access of this particular variable or shared variable, I should say, both the process will be looking upon this particular semaphore, right, in order to avoid race condition, and obviously n is the number of seats available, right? Now let us come and see the other body of this particular process. Now talking about the next thing in the while loop. Sam wait cust ready, right? So this is the wait operation where the barber is waiting for the customer. See, initially there is no customer in the shop, right? So what is cust? Sam wait cust ready signifies over here that right now barber is waiting for the customer to come, right? And right now, because the value is initialized to 0, there is no customer in the shop, right? So no customer is over here, right? So this cust ready is 0. Now as soon as this will be, now the thing is, this will be working with the customer process. So now imagine one customer came in the in the shop. So what that particular customer process will do, that customer process will change this value to 1, customer process, right? And as soon as this value becomes 1, the value Sam wait get to notified itself that okay, now it is one customer in the shop, right? So the first step is no customer is there in the shop and barber is waiting, right? And then the second thing, as soon as the customer arrives, right? As soon as the customer arrives, or if there is any customer, what will the barber be doing? The customer will be in the waiting room, right? So barber will be going to the waiting room, right? And asking the customer, okay, come to my chair and let me cut your hairs, right? So in order to do that, what it will be going to do, it will be increasing the number of free seats. See, customer is in the waiting room, right? He is occupying one of the seats of the waiting room. Barber will go to the waiting room and he will find that yes, there is a customer. So that barber will ask the customer, please come and I will cut your hair. So the customer will leave the chair of the waiting room. So here the number of free seats will be increased by 1, right? So in order to increase the number of free seats, this semaphore, that is access the waiting room seats, this particular point is going to operate over here. This barber will be getting the access of number of free seats with the help of this particular wait operation, right? If this wait operation is successful, then the barber will be modifying the number of free seats, because now it is taking one customer out of the waiting room. After that, if the customer get finished his cutting the hairs, right? When the barber finishes the cutting of the hair of the particular customer, it will be notifying everybody that I am busy. Right now I am cutting the hair, so I am not free right now. So it will be notifying everybody that I am busy right now, right? And because now he has done the modification of the number of seats, so here he will be going to free the access to the waiting list so that any other customer can come and occupy the waiting room, right? So that was the sequence of the barber process. I know it can be a little bit difficult to understand in the first go, so you can watch this video again, right? And just make sure that all these points are pretty much clear to you, because this is all the thing which is very important in order to perform synchronization, right? Now I will be moving to the customer process, and that will somehow make you more aware of this problem. So again, the things that we have initialized in the barber process are exactly the same for the customer process, right? So there will be 3 semaphore: cust ready, barber ready, and access to waiting room seats, initialized to 0, 0 and 1 as it is in the barber process, and one of the integer, which is the number of free seats, initialized to n. Now let us see what the customer process is all about. The first step, whenever the customer enters the barber shop, right, he will be seeing 2 things. The first thing is either the barber is free or busy, right, or he will be going into the waiting room, right, and see if there are free seats over there, right? So what he will be checking is this variable n, is it free right now? Remember the race condition, it is the shared variable, right? Only one process can use it, either the barber or the customer, right? So what customer comes in the shop, first thing what he sees, he look into the waiting room, whether I have the access to the waiting room or not. Because after entering the waiting room, he will be modifying this particular variable. He will be decreasing it by 1 by occupying one chair. So number of free seats will get decreased by 1. On every entry of a customer, it will be decreased by 1. So he sees if this particular variable n is free or not. So the guiding semaphore for it is access to waiting room seats, right? So it will be checking whether it has an access or not, right? Now suppose he get the entry, right? Now he is in the waiting room, suppose, right? The n was free and now the customer is in the waiting room. Now he will be seeing if the number of free seats are greater than 0. See, in order to occupy a free seat, there should be some free seats, right? So in that room, he will be seeing if there is any chair free for him, right? If there were free seats, then you can see that he will be coming into the room and he will be checking if the seats are free, right? Now if the seats were free, what he will be doing, he will be occupying one chair, right? Because of occupying one chair, you have to decrease the number of free seats by 1. Pretty simple it is, right? And after that, he will be signaling that okay, there is one customer. Remember, cust ready notifies the barber, right? So he is going to signal cust ready, right? Okay, he will be saying that okay, there is one customer in the shop, right? And after that, because he is now done with the modification of the shared variable, so he will be freeing the excess WR seats semaphore, so the other customers can manipulate it or the barber can manipulate it, right? Remember, that is the shared one. So the slide says the same. If there are free seats, occupy one, notify the barber through cust ready, and unlocks the number of free seats variable so that any other can modify it, right? And then waits for the barber to get free. That is the thing which is done by the customer. Now the else portion. Suppose the customer is in the waiting room, right? And there is no free seats. See, there are no free seats, right? You entered the shop and you found that there are no seats available. So you're going to leave the shop, right? So before leaving the shop, you have to release this particular semaphore because you have acquired it. Remember this step, you have acquired that particular semaphore, right? Now because there are no seats, so you cannot occupy any seat, right? So you will be leaving that particular semaphore from your possession, right? So the last thing is that if there are no seats, leave the room and unlock the number of free seats because you are holding it. Why you are holding it? So that you can occupy one seat, right? But there are no seats, so leave it so that the barber process can occupy it, right? So I will be recommending to watch the video again from the barber process and customer process once again. Write the problem yourself. Think about the scenario, no customer in the beginning, one customer comes, see the waiting room, barber gets free, notification and all. Just write it down, the code, and go through the scenario one by one, and this particular problem will be clear to you, right? So that was all with this video. I hope that you understand this particular problem, and for more such videos on operating systems and other subjects, stay tuned to my channel. Thank you.